Well, hello there again, friends. Today is 3/5/2022, and today is the Odin Project Vlog Day 72. And today I completed CSS Units. It was meaty, very meaty. Lots of reading today. Um, no text editor today. Um, just a whole lot of reading. So we'll kind of approach this like we did the last couple. I'm going to go down and do the knowledge checks, and then we'll circle back to the articles. So, um, so today was about everything related to different unit sizes in CSS. So that'd be like pixel size for like um, absolute values, and you have relative values for like EM or REM, and then you have viewfinder, viewport, excuse me, sizing via VH, VW, Vmax, Vmin, and then so that's kind of what today's about. So let's go through these real quick here. Sorry, I should have read that. The question is, why would you want to use EM or REM for font size instead of PX? And essentially, without reading this into this too much, EM and REM both refer to a font size, though they are often used to define other sizes in CSS. You'll see both of them often, so we're going to explain both. But as a rule of thumb, prefer REM. And so they go into the difference. Basically, 1 EM, I think of it as like a factor. So a factor of 1 EM means that you're going to have the EM, I don't remember exactly what it stands for, neither here nor there. The 1 EM basically means it's going to size or shrink relative to its parent element. So if it's a div inside a body, for example, the first div, it's going to, you put 1 EM in there for the font size, and it's going to size according to the parent, which is body. So if body is either reduced or enlarged by a certain size, 1 EM will follow right along with that. The reason why the articles state this in the text here too, EM is, well, I guess I should explain what 1 REM is. So conversely, the difference mainly is you still have the factor of 1 in front of it, so that's always a factor of 1 if you have 1. And then the difference between EM and REM is relative to the size of the root element. So think of like HTML, and it even says here either root or HTML. So 1 REM or anything REM is preferred over EM because you have instances where your code base might change because, say, you have somebody on a mobile device, or they have a hard time seeing. They're not using a screen reader, because they're not blind, but say they have a hard time seeing, their eyes are bad, so they'll do what I do here with you guys, is they'll zoom in 150%. Well, the problem with EM is when you do that, it may not necessarily be a 1-for-1, because if your parent element doesn't change inside of here, so if you have a div inside a div, and that parent div doesn't change in size when you zoom in, your current 1 EM div is not going to change either. I hope that made sense. Versus a 1 REM will change, because when you're zooming in, the HTML is itself zooming in. So when we go like this and we zoom in, we're actually we're changing the HTML, the body, the root of the page. And so 1 REM is going to also size. So if this text paragraph right here, for example, was font size of 1 REM, it would size just like it is, along with as we zoom in and zoom out. So I hope that makes sense. So that's why it's preferred. And then your factors. So another example here is 16. So 4 rem will be a factor of 4. So if you're using 4 rem, it would make 64 pixels, which means if your element's font size is 16 pixels, you just multiply 16 times 4 is 64. So 4 rem, or excuse me, 4 em would, or 4 anything, or rem, 4 em, whatever, would equal 60. It would be equivalent of 64 pixels. But remember, it's relative. They're just giving you an example, let you know what that 4 is doing. So it's a factoring situation. And then the second question is, what are some instances where you might want to use VH and VW? So it says the units VH and VW relate to the size of the viewport. Specifically, 1 VH is equal to 1% of the viewport height, and 1 VW is equal to 1% of the viewport width. These can be useful anytime you want something to be sized relative to the viewport. Example including full height heroes, full screen app-like interfaces. So the articles go into much greater detail about viewports. So I won't speak about them too much here because it's kind of a rabbit hole, and I'm not gonna sit here and tell you that I fully understand it myself. This third article goes into it, fun with viewport units, and we'll go over the articles just briefly, but all the content's in there. And then the third question is, what are some instances where you might want to use pixels instead of a relative unit? And this narrows into the second article actually in the knowledge check, the CSS Units, I think. Is that the Cody? Yeah, the Cody page. So the question was, what are some instances where you might want to use pixels instead of relative unit? Okay. So this does a really good job of kind of like stepping you through the EM, the rem, and the pixels, and he goes through and talks about what he recommends, and he, just like Top recommends, he recommends using rem over m, or em, using rem over em for the reasons I already explained, and he talks about the implications. I basically just summarize this entire article. See, he goes into details of what happens. So this on the left is the, if I remember right, jog my memory here. So the left card uses rem and the right card uses pixels. In this particular example, he said he would prefer the pixels over the rem because, excuse me, because it doesn't bloat up the size of the div that card that fast, that wrapper that fast, that hard, like it does when you use rems. Because remember, everything's expanding together, so that is expanding because it's getting its base font style from the parent, versus this is staying in pixels, so it's very absolute, and that's why it's not scaling the same. But he likes it because it takes up less space, and it's much more friendly, if you will, when you're trying to work with hero pages like we've worked with before in the other exercise, the landing page exercise from a long time ago. Is this is the left side, this may not be wanted, I guess, is that growth. And then he talks about conclusions here. And to answer the question, that's kind of actually where I wanted to take you with that. So here is where so kind of just explain that. That's where pixels might be a better solution. So let me see what he says in here, if he has anything concise. It might be better to simply use PX for everything if you are having a hard time accommodating flex text wrapping and overflows. And that's where basically I was talking about, where you have like a hero layout, or you have everything's flex container and flex items, but yet you're not able to accommodate the wrapping and overflows, it might be better just use pixels so that this doesn't happen, where everything just gets bloated up so much faster. Basically, where you run out of real estate on the page. Basically, you run into overflow issues, and you can code those in your CSS. We've talked about that and looked at that, and I've actually done that before and highlighted that for you guys. But he's just suggesting that sometimes having that stationary absolute value in pixels is just easier to work with. That's all. Sorry if that was overly wordy. And so we already went through that article, so that was the middle one. So the first article here is CSS Values and Units. This is a very an MDM web doc, very long, and textbook-like style. There are some exercises in here. Well, not exercises. There's nothing for you really to do except interact with it. But it's cool to go through the wrapper and change the size to see how it behaves when you change it to, for example, 1EM to, 2 times factory EM. See how everything changes. I won't go over all that because there's a lot in this article, but I encourage you to go through that and study that and play with it, play with the values, change them around. Here they're talking more about the parent-child relationship nature of using rem and m and the differences. Again, here's rem and m example inside of a container that's called wrapper that has a solid or has a 400 pixel absolute width, but yet the internal boxes, the internal divs are relative, which you see right here, percent width 40%. This is an example of using percentages. I won't go over that, but that's went through in this article. Here's an absolute, and this shows the differences and how that works. And they talk about art. They talk about coloring, numbers, opacity of a box, values of that, colors, interacting with colors, using their I don't want to call it pseudo case, but like their common name instead of using RGB or hex. And then it shows you how you do that with RBG and hex, and then they talk about RBGA, which is red, green, blue. A is your opacity, but A actually stands for, I think it's attribute. I don't exactly recall. I read this, but alpha channel. I knew it was something weird. They call it the alpha channel. And then they goes over HSL and HSLA values. Again, alpha channels, which is your opacity. Nothing we haven't seen before. You may not have played with this stuff in your CSS, but just getting a little more familiar with it. And positioning just goes on and on and on. Talks a little bit about functions. Saying basically how CSS has functions like RGB and HSL are actually, I never thought about this, but they're actually a function inside of CSS, along with when you use a URL for a file, that's a function. Calculate, which they talk about in this article, I kind of sped over it, but is a CSS function. It's interesting. I never quite thought of it like that. So that's pretty cool. Again, a pretty dry read. And the last one's fun with viewports. So this is not bad. This is a CSS tricks article that goes over the do's and don'ts with using viewport. And this is an example of the bad part of a viewport, how this can get you in trouble because you see how it scales too fast. And they talk about a workaround with that by using, oh no, I'm sorry, the MDN didn't talk about calculate. They may have a little bit, but this article talks a lot about calculation, and you can use the calc, I guess I should say, function, the calc function of CSS to, in this example, you're going to start out at 16 pixels, and you're going to add 0.5 viewport width to every 16 pixels of width, and that will actually take care of this to where it scales better and it doesn't shrink and go crazy like that so fast. So that's basically the skinny on that. And of course, fortunately, there was a little bit of a learning gap here because I got a 404 here and it's just broken. That's unfortunate because it was going over more calculations and further understanding of how that works. So you kind of have to just use your imagination, or you could go to Google, because that code pen is in fact broke. To comment in here and talk a little bit about more calculations, which I'm not gonna lie, I didn't completely understand. I get what it's doing here. I get the calc feature and I know what it's doing, but I don't understand their comments and how it relates to the calculation itself. So if you guys understand what that means, put it in the comments, because I'm not even going to take a stab at it. But let me know in the comments what you guys think of that. So, and then it just goes into more layouts, sticky footers, some things cool things you can do with viewport and with that, with sticky footers and making them, changing around max width, min height, to accommodate. Again, I'm speeding up because I don't want to make this video really long. And it ends up talking about breaking containers. If you're, we talked about earlier, where you get stuck inside a div, not maybe by your own making, but maybe using a content management system, stands for CMS. If you're bound by that and you have a reason to break out of that container that it's sitting in, you can do that with this code here, and it talks about why it does that and how it does it. And it talks about things that are getting weird. Some people thought this was a good idea to do a scroll indicator, and then it's a lot of lipsum here, but then there's a little text at the front here talks about why this is probably a hack-up job and not a good way to do things, but it does work. But some warnings on this technique that you may want to avoid it. So with that said, that is all for today. I know I went really fast, so if you need further understanding, just replay the video again. So hope you guys learned a little bit and enjoyed the ride tonight. Please like, share, and subscribe for more content. Excuse me, and leave a comment below and let me know what you guys think of this particular section on this information, and what you think of this section here. If you have it figured out, you can let me know in the comments. So other than that, with all that said, until next time, see ya.